Hi everyone. Good afternoon, guys. Very good afternoon of you. How are you all? Hope you're all doing well. So we'll be continuing our the series, quick revision series on this highway engineering. So we are in the discussion of which one you can say all of you. We are in the discussion of this rigid pavement. Na? So no, we are in the discussion of this rigid pavement you can say, and we'll be continuing our discussions on this rigid pavement you can say, right? So up to which part we have discussed? We discussed some portion of this rigid pavement and we'll be continuing discussion on this other portion of this rigid pavement you can say, no? Right here. Before we proceed to our discussions, right, what is that we'll be having you can say. So this have a quick revision, right? All of you, welcome to Unacademy. All of you, welcome to Unacademy. Let's crack it, right? Everyone be ready to crack, all of you. So what is the referral code you have to use, right? RP Civil is the code you have to use always, right? Now, so this is my profile, you can follow me at which, and what is the referral code you have to use always, right? That RP Civil is the referral code you have to use always, right? So these are GATE 2024 rankers from Unacademy, those who secured AIR 1 and up to May 18th, all of you, right? So tomorrow will be the last date for availing this offer. You can unlock your path to the selection by preparing for this GATE 2025, all of you, right? So this is a 9 months subscription you can avail it. Which one? This is 12,999, all of you, okay? So what is that referral code you have to use, right? RP Civil, right? And for a 9 month duration it will be 12,999, and for this 24 months duration it will be how much you can say, 24,999 you can say, right? So it's like almost 1,000 per month, right? It is like generally whenever you are going to multiplex, right, obviously 1,000, 1,500, 2,000 will happen amount of. So it's like monthly going to a movie, right? You consider it like that, right? That much a small price you'll be getting, you can say, right? And this offer is valid up to which one? This May 18th only, right? Beyond this May 18th, right, this offer is not valid, right? You have to be careful, right? Right, you have to be careful. Now here, so these are the latest batches starting, right? Pratigya batch for this GATE ESC PSUs 2025 on May 17th, right? Geotechnical by this Abhishek sir, and mathematics by this Gurupal sir will be starting, you can say, all of you. So don't miss this, anyone. Those are willing to start your preparation, right? New batch for this GATE and ESC 2026, right? These also starting on which one? This May 17th, you can say. And now, so those who are taking iconic subscription, they'll be getting these books printed, right? So these civil engineering books, right, printed books delivered to your home, you can say, within 15 days of which one? This your subscription, right? Within 15 days of your subscription, right, they will be delivered, right? As now, so don't miss this, right? Now, so we'll be going on to which part, you can say, if you just observe. That rigid pavement already we have started, that previous class we have started, right, under this rigid pavement. Once this rigid pavement is over, we'll be entering into which one? This we'll be entering on to which part, you can say, that traffic engineering, right? After traffic, this will be over, you can say, right? So this is the previous class, if you just observe, yeah. So this was done. So what is you can say, rutting, failure, fatigue, flexible pavement, everything gets over. Indicative VDF values, right? This is your rigid pavement we have just started, or not? Rigid pavement we have just started, you can say, yes, now so in this design life is over already. So rigid pavement design life 30 years and 20 years we have taken, right? Because these are different from that of your flexible pavement values, no? Because in the flexible pavement those values are different, and in the rigid pavement those values are different, flexible pavement those values are different, and this rigid pavement those values are different, right? Standard axles also defined, you can say, right? 251, that is your 252, right? For other axles also, right, what are the different standard loads we have to select, right, we have defined. So apart from that, right, CSA, rigidity factor, and this vehicle damage factor, lane distribution factor, equivalent single wheel load factor, equivalent axle load factor, or equivalency factor, all are similar to that of your which one, you can say, all are similar to that of your which one, all of you, similar to that of your flexible pavement only, right? So we are not writing separately. Extra parameters are which one? radius of this relative stiffness and equivalent radius of this resisting section, those things L comma B. And what is this one? These are the different stresses we'll be having. These are your different stresses. You can say, right? Nature of this wheel load stresses we have seen, right? 257. Just nature of this wheel load stresses. Whenever it is interior wheel load, load is acting at the interior portion of this so then what is it you can say? When load is acting at the interior portion, what happens? It is acting like a simply separated slab. So whenever it is acting like a simply separated slab, so what happens? Top compression and this bottom tension, edge loading, simply separated beam, you can say same top compression and this bottom tension also. Corner loading rate, what is it you can say? Top tension and this bottom compression, because it is having which one? Because it is having which one you can say? Because it is having this cantilever behavior, if you just write, isn't it? Now, so shall we see first the values of these wheel load stresses? Then after that nature and all these things we'll see later. Right. So this is your 257. So this 22nd class quick revision of this heavy engineering at rigid pavement part 2 you can say is now. That is your 257th point. And now 258th point you can say, right? What is it? 258th point. This is your first slide for today's class. So what is it you can say? Wheel load stresses, nature of wheel load stresses we know, and the values of wheel load stresses we have to see, wheel load stresses, right? What is it you can say? Values, right? So what are these values of this wheel load stresses? If you just observe, there are a different formulae you are having, right? What is that? You can say, if you just observe, Westergaard formulae as well as this IRC formulae. Okay. So what is that Westergaard's formulae? So Westergaard is the fellow who gave the formula for this slabs, right? Because we are considering this slab action for this rigid pavement, so we need to also consider the same parameters as that of your slab only, right? Westergaard's formula. Next, what is it you can say? That IRC formula. Westergaard's formula as well as which one? This IRC formula, if you just observe, right? Now, three different loading conditions are there, and we have to calculate the stresses at these three different loading conditions only, right? What are these? What are these different loading conditions you can say? Three different locations. What are these three different locations? If you just observe, the three different locations will be what you can say? The three different locations will be interior loading, next edge loading, as well as which one? This a corner loading, So now what is the first one you can say? Sigma I. What is it? Sigma I? SI, right? Sigma I, or this is SI is nothing but your which one? This stress at this wheel load stress at this interior portion, right? Just no other suffix is given, means just sigma or this SC is given, means, right? What is it you can say? What is it you can say? It is wheel load stress, 0.316 P by this H square into what is that you can say? 4 log L by B. You have to remember, because sometimes they may be asking you to identify the formula directly, right? Log to the base 10 plus which one? This 1.069, right? This is given by Westergaard, right? First one, sigma I, IRC formula for this interior loading, right? Sigma I or this SI, if you just observe, right? It is the same, right? What is the meaning of this? Do you can say? Do is nothing but your same, if you just observe, right? Next, what is the second one you can say? Edge stress, sigma E or this SE will be equal to, right? How much you can say? 0.572 P by this H square into what is it you can say? Same, that 4 log L by B to the base 10 plus what is it you can say? 0. Just instead of 1.069 it is 0.359. But what happens that this IRC formula has been modified, you can say, if you just observe, what is it? Sigma E or this SE will be equal to, right? How much you can say? 0.529 P by this H square into what is it you can say? 1 plus 0.54 mu into what is that you can say, into, if you just observe it, what is it, 4 log L by B, 4 log L by B to the base 10 plus this log B to the base 10 minus 0.4048, is not? So that is what you are having. Next, so what is that you can say, corner stress rate sigma C, right? Sigma C will be equal to that, SC will be equal to which one? That is your 3p by h square, right? You have to remember this corner formula differently, but for the other formulas, right, what is that you need to remember? Which parameters are involved in that formula, you have to remember, right? But here complete formula you have to remember for this corner, right? 3p by h square into what is that you can say, 1 minus what is it, a root 2 by L whole power how much, 0.6. Here that is sigma C will be equal to that SC will be equal to what is that, IRC corner stress V load stress formula. So that is your 3p by this h square into what is it you can say, same 1 minus a root 2 by L whole power which one, this, just instead of this 0.6 we are having this 1.2, right? That is the only change, right? There is no other change you are having if you just observe, right? Is it right? There is no other change you are having if you just observe, right? Is not? No. So here, which one you can say? This corner stress formula you have to remember compulsorily. So what is it you can say? Corner stress given by this Westergaard is lesser than which one, this corner stress given by this IRC, right? So what does it mean, you can say, it means that IRC formula are more conservative than this Westergaard's formula. What is the meaning of this more conservative, you can say, safer side they will be giving which one, this more, right? Safer side means, right, what is it you can say, what is the safer side, right? What is it you can say, safer side means, right, safer side it is giving, right, like that you can say, isn't it? No. IRC formula will be giving higher stresses, right? Whenever it is giving higher stresses, now you will be designing for this higher stresses, means what is that you can say, safe side or not, obviously, yes. So I'll be writing that point in the next slide, you can say, that is your 258 and this is your 259. So what is that IRC formula? IRC formula are more conservative than which one, this Westergaard's. So IRC formula are which one, this more conservative than which one, this Westergaard's formula, right? Why it is like that? Since that a root 2 by L is lesser than 1, so automatically what will happen, that a root 2 by L power 0.6 will be higher than which one, this power 1.2. Now higher powers will result in this lesser value, right? Because this value comes to be lesser than 1, as now this kind of situation will arise, right? So like that. Now next stress will be which one, this warping stresses, warping, or which one, this curling, or which one, this folding, warping or this curling or this folding stresses, right? So these are mainly due to which one, if you just observe, this warping or this curling stresses are mainly due to which one, you can say, these are mainly due to what is that, these are mainly due to which one, these are mainly due to which one, you can say, these are mainly due to what is that, if you just these are mainly due to this these are mainly due to this what you can say, temperature variation, na? Yes or no? temperature variation, you can say, if you just observe, right? Isn't it? Temperature, which one? This variation, if you just observe. What is the temperature variation, right? Which temperature variation? Summer to winter, winter to summer, or which one you can say? Or daytime to nighttime, nighttime to daytime. That is your daytime to nighttime, and this is nighttime to daytime, na? So these are due to which one? This daily temperature variations or not? These warping stresses and nature, if you just consider. So these warping stresses are mainly due to what? Daily variation of temperature. Daily variation of which one? Daily variation of temperature, you can say, right? Suppose if you just consider this daytime and nighttime, if you consider, whenever it is the daytime and whenever it is at night time. So what is it during the daytime, right? During the daytime, who will be there? Sun will be there, no? During this night time, who will be there? That moon will be there, right? Now whenever you are considering your pavement, if you just observe, right, what happens? So this top temperature will be T1 and this bottom temperature will be T2, right? Which one will be higher? Definitely that a T1 top temperature will be higher than this T2 bottom temperature, na? So top expansion will occur and the bottom what will happen? Right, bottom contraction will occur, if you just read. Top expansion will occur and this bottom contraction will occur, if you just read. So now it will be expanding in this manner. The deformation profile comes to be like this or not? The deformation profile comes to be like this, if you just observe, right? The deformation profile comes to be like this, if you just say, isn't it? Now, so top expansion, bottom contraction, right? That expansion will be, if expansion means increase in the dimension, that increase in the dimension, how can you avoid? By applying the compressive resistance, na? So that a top compressive resistance you have to apply. Bottom contraction means decrease in the dimension, how can you avoid that? How can you avoid that? By means of this tensile resistance or not? By means of which one? This by means of this tensile resistance, you can say, right? By means of this tensile resistance, you can say, if you just read, is it? No. So what is that you are having at this top? If you just observe, right, what is that? At this bottom, if you just observe, what is the nature of the stresses? Okay, I'll write it the below because the space is not available. So at this top, what is the nature of this stresses, you can say? That is a compression, na? Nature of this stress is a compression at the top, because expansion will be resisted by this compressive stresses only. At the bottom, right, what happens, you can say? Tensile stresses, na? At the bottom, because contraction will be resisted, right? These are applicable for which one? These are all the three locations, right? Interior, edge, as well as this corner, right? Now what is that we are having, if you just observe here during this daytime, right? It is warping or this folding in which direction? Upward direction or down direction? It is your warping down, na? So here it is like this, higher temperature at the top, lesser temperature at the bottom. It is getting folded in this manner, you can say, right? So what is it you can say? That is your warping down or not? That is your warping down, you can say, is not? Now coming to this nighttime conditions, right? During this nighttime conditions, right, what happens? Earth temperature, bottom temperature will be higher and this top temperature will be lesser, you can say. So this is your T1 top temperature and this is your T2 bottom temperature, and what happens, you can say, this mama will be there with his 27 vibes, right? Which one is higher? If you just observe that T1 will be lesser than this T2, na? So bottom expansion will occur and the top, what happens? That contraction will occur, right? So whenever it is like this, right, what happens? This bottom expansion will occur, right? What is the bottom expansion? If you just observe, expansion can be resisted by which one? This is a compressive, which one? This expansion at the bottom is resisted by this compressive resistance, na? contraction at the top will be resisted by which one? This is a tensile resistance, na? Isn't it? Resisted by this tensile resistance, right? So if you just observe what is the nature of this stresses at this top and bottom. At the top it will be tension, na? At the top it will be tension, and at the bottom, right, what is it you can say? At the bottom it will be compression, na? So these are applicable for which one? This is interior edge as well as which one? This corner, right? Now if you just observe, temperature at the bottom is higher, temperature at the top is lesser, means right, how it is doing? It is getting folded like this, na? So whenever it is getting folded like this, right, it is called as your warping or this folding up, you can say. That is your warping or which one? This is a folding, na? Both up will be taking. Warping or this folding up, you can say, right, like that. So we'll be having this if you just observe. So warping stress under which condition, you can say? Warping stress under which condition, you can say? If we just observe, warping stress under this daytime and this nighttime condition, na? Warping stress under which condition, you can say? That is your daytime and this nighttime conditions we have seen if you just observe. Is it? Yes, na? Like that. So here nature of this warping stresses is only important for us, or amount of this warping stress is also important, right? Amount of this warping stress is also important, obviously, na? Yes, that amount of warping stress is also important, right? That is your 260 and this is your 261 point. If you just observe, right, what is that warping stress values? So these are given by which one? Bradbury, brother of Cadbury formula, na? These are given by which one? This Bradbury's formula, right? What are these Bradbury's formula if you just observe? So warping stress, temperature stress at this interior, or you can also give the symbol W, warping stress at the interior, that is equal to which one? E alpha delta T. Delta T is the change in the temperature from daytime to nighttime and nighttime to daytime. E alpha T by this 2 into, what is it you can say? Cx plus this mu Cy divided by this 1 minus mu square. That is for the interior portion. And temperature stress at the edge or this warping stress at the edge will be equal to which one? How many edges will be there? One edge is along the length, other edge is along the width. And I read E alpha T by this, E alpha delta T by this 2 into Cx, or this is along the length, na? Divided by, or you can say it as which one? E alpha delta T by 2 into, what is it you can say? Cy, right? That is along the width, you can say if you just observe. Is it? Whenever that warping is occurring along the length, right, this will be used, na? Whenever the warping is along the width, we have to use this, na? That Lx will be the symbol used for which one? This length. Ly is the symbol used for which one? This width, you can say. Now STC or SWC, right, warping stress at the corner or temperature stress at the corner, right? What is it you can say? E alpha delta T by 3 into 1 minus mu into, what is it you can say? Under root A by L. What is that A, you can say? Radius of this wheel contact area, equivalent radius of this wheel contact area. Originally it is rectangular curve, but we are converting that into which one? This equivalent circular, na? Yes. L is radius of relative stiffness or radius of area over which stiffness is required. That is what. Or it is the radius of this area over which what happens, you know? Radius of this area over which what happens, that deflections will occur, right? Wherever deflections are occurring, there only we need that stiffness, definitely or not? Yes. Suppose if deflections are not occurring, right, what is it you can say? Deflections are not occurring, right, what is it you can say? Stiffness is required or stiffness is not required, you can say, right? Stiffness is not required. Already stiffness is there, is not? Right? So this is your 262. If you just have it, next one, what are these stresses? You can say frictional stresses. Frictional stresses, right? What are these frictional stresses? If you just observe, these are mainly due to which one you can say? These are mainly due to that seasonal variation of this temperature, na? These are mainly due to the seasonal variation of this temperature. You can say if you just observe, right? Isn't it? So what are these seasons? If you just observe, summer as well as this winter, na? So whenever it is that is summer, so frictional stresses, right? Just nature only we will consider. Will not write the values. After that we'll write the values, right? And nature of this stresses, right? Whenever it is a summer, what happens? Tell me. Whenever it is a summer, na, top and bottom expansion only will be there. Whenever that top and bottom expansion only will be there, that top and bottom expansion will be resisted by which one? This top and bottom compressive resistance, na? Just now we have seen, right? Top and bottom expansion will be resisted by this top and bottom compression, you can say, if you just observe, right? Right, so top expansion, bottom also will be having which one? This expansion only, right? So both expansion means it will be expanding like this, na? It will be expanding like this, you can say, along the length, along the width also it will expand, you can say. I'm just showing it for one. So that a top and bottom expansion will be resisted by which one? This top and bottom compression, na? Obviously. Who will be creating that compression? That friction will be creating that compression or not? So what is that? Coefficient of friction into that normal reaction, right? So coefficient of friction into, right, what is it? You can say that half of this weight, na? Like, so here if you just observe, what is the nature of stresses at this top and bottom? At the top and at the bottom, if you just consider, na, what is the nature of this stresses at this top and bottom? You can say top and bottom it will be which one? This expansion, top and bottom expansion will be resisted by which one? This top and bottom compressive stresses. Compressive. So these are applicable for what? For this interior portion, edge portion, as well as this corner portions, you can say, right? Like that is the nature of which one? This frictional stresses. Next. Next, that is your which one? This is summer, na? So similarly, directly I'll be writing. Similarly, right, what happens in winter? In winter, what is it exactly? Reverse process will happen. At the top and bottom, right? Whenever it is at this top and bottom, right, what happens? You can say. Whenever it is at this top and bottom, right, what is it? You can say the nature of stresses will be which one? This tensile stresses, you can say. Nature of stresses will be what? Tensile stresses, right? These are applicable for which portions? Interior portion, edge portion, as well as which one? This corner portions, right? 262. Now 263, nature of this frictional stresses we know in summer and in the winter. What is it? Values of this frictional stresses, if you just observe, right? How can you get that if you just observe this frictional stresses? Yes, Fi. What is it? SFI? Frictional stress at interior. Yes, Fe. Frictional stress at the edge will be equal to which one? F gamma C Lx by 2 or F gamma C Ly by 2. The first and foremost one is what? Along the length, na? Lx is there along the length, right? This is which one? along this length and this along this width if you just put. These are applicable for what? Summer as well as winter, right? Summer as well as which one? This winter, you can say, right? Now what is that frictional set? This a corner that is approximately equal to which one? This 0, you can say, right? This is approximately which one? This is 0 if you just observe, right? Like that. Okay, so now whenever you are considering, right, what is that you can say, right? Okay, this is what we'll do it for today, and in the next class we'll continue our discussions. Thank you all guys, right? Anyone having any doubts anywhere? All of you, any doubts, anyone?